And what I'm going to say is that the bio-based chemicals industry and all of the innovators that are looking at sustainability and non-fossil carbon, we've created a toolbox. We've spent decades and billions of dollars creating this toolbox. And what this toolbox does is it gives us all the skills and knowledge and know-how to rewrite that story. You know, we can write a happy ending.
Hi everyone, and welcome to the latest episode of Biomarket Insights TV. My name is Paul MacDonald, and I'm delighted today to be joined by Dr Sarah Hickingbottom, who is the General Manager of Circa Group. Circa Group is a leading biotech company producing unique and highly valuable biochemicals. Hi Sarah, how are you today?
I'm great, Paul. Pleasure to be here.
Thank you very much for your time. It's great to have you on the show. So Sarah, today's episode is entitled Turning Waste Biomass into Sustainable Biochemicals. And I think our viewers are going to be really interested to learn about your processes, the benefits of sustainable solvents, and the role of bio-based chemicals in decarbonising industry. So lots of meaty things to get our teeth into. I think what would be great is before we start talking about Circa Group specifically, perhaps you can give me a bit of background as to how you first entered the sector, your journey, and what brought you to your current role at Circa.
Great. Well, I studied chemistry. I went to Imperial and afterwards went to Los Angeles and studied for my PhD at UCLA with Fraser Stoddart. And when I graduated, I realized I was fascinated by chemicals in the real world as well as R&D, and joined a consultancy firm. So petrochemicals, materials, foods, etc., and got a taste of all sorts of different aspects of the chemicals industry. And through that, I started projects connected to oleochemicals, and I was absolutely smitten. Oleochemicals, these are chemicals from vegetable oils, from animal fats. There's well over 15 million tons of these chemicals produced every year, have been for 60, 70, 80, 90, well over 100 years. We use them every day. And alongside that were biofuels, glycerin, and then the agricultural commodities that were their feedstocks. And that was it. Bio-based was the future for me. So I left the consultancy and went to a different organization, an economics consultancy called LMC International. An SME, but absolutely at the top of their game, connected to supply chain economics, price forecasting, what's the realities of the world. And they're all predominantly agricultural economics, as I said. And what I did is focus on the bio-based chemicals, the oleochemicals, the biofuels. And that led me into working with big agricultural players who were looking to add value to their agricultural feedstocks, to major chemical companies that were beginning to recognize that they could enter this new supply chain, acting as a conduit between the two, because governments play roles in agriculture that don't in chemicals, etc. So it was very much a case of facilitating. And then all of the new innovations that were coming through, worked a lot with small companies that were looking for due diligence work for investment, etc. And this was absolutely fascinating all around the world with government organizations, economic development boards, and all sorts of things to see how we can bring bio-based chemicals into reality. And as part of that work, I was then invited to become the CEO of a cluster in England, BioVale, an innovation cluster out of the University of York, focusing on Yorkshire and the Humber. And there are two clusters in the UK predominantly in this sector. And I could talk about clusters all day, but effectively they're about magnification and the acceleration of new innovation and technology. And so I jumped ship, took on this new role. And that was really a lot about working with policy, lawmakers, regulators, startups, entrepreneurs, financing. And that's how I met Circa. And Circa, the development work in the chemicals that Circa is commercializing came out of collaboration with the University of York. And so in April this year, I took on this new role, and the challenge is amazing.
Well, that's a great story, and I can clearly see the sort of the enjoyment and the passion and the enthusiasm for the bio sector is coming through that introduction. It's great. So I guess moving on to Circa Group. Sorry, you joined Circa when exactly?
It was April this year.
April this year. Okay. So maybe you can give our viewers a quick helicopter view of the business and how it's structured.
Well, I mean, April this year was a fascinating time to come on board. Circa's growing a lot. Had an IPO in March, and so have raised funds, now floating on the Norwegian Stock Exchange. But effectively, to take a step back, yes, bio-based chemicals. Circa, what do we do? We take waste biomass, so cellulosic biomass. I can talk about that in a little more detail later on, and convert in one simple step to levoglucosanone, LGO. This is a platform chemical. It's a chemical that's not been available to industry at scale previously, and it really takes on board the chemistry of nature's biomass. So it captures the oxygens, the stereochemistry, the functionality. It's a platform chemical. What does that mean? Well, it effectively means there's well over 100 derivatives that you can make from LGO. And that's what Circa does. We produce the LGO, and then we have an opportunity to form a host of different bio-based chemicals. And our first flagship commercial chemical is dihydrolevoglucosanone. We've trademarked it Cyrene to avoid that quite long name. And Cyrene has many, many different applications as a substrate, but absolutely fascinatingly as a solvent. So it is a bio-based solvent. So yes, Circa, we were founded and still have our CEO and core staff in Australia. Our UK business has been around for some time. As I mentioned previously, collaboration with the University of York and James Clark at the Green Chemistry Centre of Excellence has been fundamental to the R&D. We're now in Norway, moved our corporate headquarters there, and we are building, which we will be talking about, our first commercial scale plant in the northeast of France. So we're very global, one of the interesting things about us is we also are going to be able to build plants in different parts of the world.
Right. Wow. So it's quite an aggressive growth over the period of since the business has been created, right?
Well, the business began in 2006, and really Tony Duncan, our co-founder and CEO, and his team have really worked for like 15 years solidly to create a technological platform that not only has market demand and the need, which all bio-based chemicals fundamentally are solutions to problems, but also an awareness of the technology. Because when you scale up, there are all sorts of challenges. And so it's to take the time to ensure that those challenges have been ironed out and that you can scale up. So we're now in a position where we're building our first plant in the northeast of France. It's a capacity of 1,000 tons of Cyrene. I should mention that that's LGO as well. It's quite high yielding to go from one step from the LGO to Cyrene. And the core point is because we've spent so much time with the engineering and the developing is that we know we can scale up. Of course, there's going to be challenges, but it's not something that is totally unknown. And then by 2030, we intend to have over 80,000 tons capacity in a series of plants. There'll be 25,000 to 50,000 tons capacity each. And because we're using waste biomass, I mean, if I take the time to mention the feedstock, what we can do is place these plants in different strategic locations, obviously connected to their offtake supply chains, the downstream, but also to take advantage and add value to agricultural waste streams, forestry waste streams. And in fact, Paul, there's only economics and scale that stops us from using the waste that's sitting in the back of your fridge right now. You got a moldy onion there? Well, you could give it to us. We can turn it. We can use that as a feedstock, technically speaking. So if we go to Brazil, we can use sugarcane bagasse. If we are in Europe, I mean, we're using forestry biomass in France, sawdust. But we could also we have an agnostic nature. Each plant has to be slightly adapted to the feedstock of choice, and obviously economics play a role. However, that really gives us a flexibility. So we can create supply chains that are resilient, they're onshored. I mean, obviously this has become a big thing since the pandemic. They're different to the petrochemical ecosystems.
So I mean, I want to sort of talk about the solvent, but I suppose you've just given an indication that, I mean, I want to focus in on the solvent because I think that's a really interesting product. But
Yeah.
the potential is incredible. Then, if you're saying you can do this from the mouldy onion at the back of my fridge, that means the potential of your technology is limitless.
Well, I'd like to think it's limitless, of course. That's a lovely way of thinking of it. Yes, I mean, obviously there are going to be some, but yeah, waste biomass. So, we're in the world of bio-based chemicals. That's what we're here talking about. And most of us who work in the sector know that biomass is cellulose, it's hemicellulose, it's lignin. And what we do is we consume the cellulose, the C6 sugars. So that's the cellulose, which could be a food crop, but because our technology doesn't need to use food crops, we don't need to use the sugarcane, we can use the sugarcane bagasse. That opens up doors, and also about circularity and about sustainability. And then alongside that is the fact that the biomass is agnostic. It does open up an awful lot of limits. Yes, exactly. So what we need is industry to work with us to create that downstream demand as well.
Yeah, yeah. Okay, well, let's focus in on the solvent product. So,
Yeah.
what is it used for? What are its advantages? And can you give us some examples of where you've provided superior value to your customer or to the value chain?
Yes, styrene. It's a fantastic solvent. In fact, it's multi-purpose. It has applications across a wide range of applications. And in fact, it's one of the first multi-purpose solvents to have been developed in sort of like 40 years. So it's safer, it's low toxicity, it's biocompatible and biodegradable and technically recyclable. So we're working from an extremely sustainable sort of foundation platform. Talking of which, its actual manufacture, not only I've already mentioned about the feedstocks being circular and sustainable, but we use less waste. It's got low GHG emissions and low water use, etc. Biochar is the only byproduct, and that is the hemicellulose, the C5 sugars, and the lignin. So its manufacture is incredibly it's incredibly strong and attractive platform. And then as a solvent itself, styrene, it is a technical replacement for NMP, DMF, and both of those solvents are labelled as substances of very high concern because of their toxicity. So these are traditional petrochemical solvents. And what styrene can do is come in as a technical replacement. So it is quite important to say it's not a drop-in, which is why we're collaborating and working together with our potential customers as we trial and develop applications. So as a business case, the replacement of a toxic chemical like NMP is incredibly attractive, not only from sustainability, but health and safety, toxicity perspectives. And indeed, you could even think far out there long term. We engineer chemical plants to account for the toxicity from the moment they enter the factory gate till their end of life. Well, if you can strip all that away, you can improve and develop processes. If we talk about end of life, we mentioned recycling, but take water, for example. If a solvent like NMP enters with water, then you are in effect discounting that water. It's not possible to treat it, to reuse it. On occasion, it has to be incinerated. Styrene is a biodegradable. It can be extracted from water, but if there were economic reasons why that wasn't viable, then you could put it through water treatment. And so it's all those different extra aspects of using a solvent that has the advantages of styrene. We've done well over 1,000 trials, and in roughly 20% of them, it also outperforms those incumbent solvents. And that's the areas that are incredibly interesting. So things like graphene, and in terms of applications, it has applications in pharmaceuticals. It's an incredibly good solvent at dissolving things. That's what a solvent does at their heart. But we also have agrochemicals, specialty chemicals, textiles, such as the polyurethane manufacturer, where you use DMF. We have recycling, so textiles recycling. We're entering a world of electronic vehicles. We want to recycle the batteries. Well, Cyrene is proving extremely promising as a replacement for NMP in that case. Flavors and fragrances, extracting things. Solvents like Cyrene is extremely good at that. But then we have polymers, paints and coatings, membranes, water treatment itself. So I think I'm showing that there is a very wide range of possibilities. And we are working with people all over the world and new possibilities.
Yeah, I mean, it's great. And I think one of the things you mentioned there, which is going to lead me on to my next question, or play a part in my next question, is that phrase end of life. Everything, I've got quite a lot of background in the packaging industry, and that is all design for end of life. And that's sort of where it starts. So it leads me on to, it's difficult to have to do one of these types of lovely conversations without mentioning COP26 and decarbonisation, but I just have. So, so tell me, how important do you think bio-based chemicals are in decarbonising industry, and what role do you think they could play in reducing climate change?
Well, they play a fundamental role. When we talk about the chemicals industry, of course, there is the carbon that's embedded in the energy that's used to power the industry. But it's the carbon that's embedded in the feedstocks, the fossil feedstocks, that we really cannot ignore. So this comes under scope 3 emissions. So if we talk about, scope 1 is the emissions that we create ourselves directly. Scope 2 is those we purchase in. So a household buys electricity, it's the actual electricity purchased. And scope 3 is when we look at the entire value chain. And non-fossil feedstocks, companies like Circa and other sources of carbon, such as waste gases, etc., the renewable carbon, because we have to face the facts that fossil fuel is not the only feedstocks for chemicals, and that we have opportunities to create new supply chains, and we should really take those opportunities. But if we talk about COP26, I really think the bio-based chemicals industry offers something else beyond what I've just said. That's the practical reality. But the other thing we do as an industry, and what Circa most certainly does, is offer the art of the possible. I'll take a step back before I explain that. I've been following COP26, as you can imagine, and I was very taken with David Attenborough's speech on Monday, November the 1st. And I've got a quote here that just hit. And he actually said, is this how our story is due to end? Is this how our story is due to end? Wow. And he went on to say, is this a tale of the smartest species that's doomed by that all too human characteristic of failing to see the bigger picture in pursuit of short-term goals? As a very stark statement, and I'm with him. I believe that that's where we are as a species right now. We have to make that choice. And so he's saying that we're writing a story that has basically a tragic ending. And what I'm going to say is that the bio-based chemicals industry and all of the innovators that are looking at sustainability and non-fossil carbon, we've created a toolbox. We've spent decades and billions of dollars creating this toolbox. And what this toolbox does is it gives us all the skills and knowledge and know-how to rewrite that story. We can write a happy ending. And it's the art of the possible, because whilst we now desperately need people to step up to the plate to make the effort and put the money in and invest in creating new supply chains, we're in a position where if we didn't have that toolbox, if the bio-based chemicals industry and all of our networks and friends hadn't created that toolbox, it wouldn't matter how much money we invested, the story would be written. But that's not where we are. We're in a position where we have the ability to step up to the plate and rewrite it's not that story, it's our story. And so that's what I think with COP26 is we want to hold industry and society, we want to hold their feet to the fire and effectively say, look, 2050 is quite a short distance away. In the chemicals world, that's 1 to 2 investment cycles. I mean, that's incredible if we really think about it. But plants are built on 30, 40, 50-year cycles. And so if we step up to the plate right now and really embrace the work that Circa and all of our fellow bio-based chemicals innovators are creating, we can rewrite the story, but we've got to do it today.
I love that phrase, art of possible. The art of possible. I think it's a lovely phrase. So I think one final question as we start to get towards the end of this episode. I think this is probably linked to what we were just talking about. It definitely will be. I was interested to learn about your role in coordinating an EU project. So can you tell me a bit more about that and how that dovetails with what you do at Circa?
Yeah, so this is our first plant. It's named the Resolute plant. It's not after the desk in the White House. It's actually about renewable solvents, etc. But we're located, as I said, in the northeast of France, and it's a EU project. It's BBIJU. The BBIJU is an utterly fantastic initiative. It's a public-private partnership from Horizon 2020, the European Commission, and private industry through the Biobased Industries Consortium. Together they form, and they're really about driving and funding and accelerating commercialization of those technologies they have handpicked to be have viability, to have legs, so to speak. And Circa has done extremely well to be chosen as a flagship project. So that's Project Resolute. We have an 11-strong consortium. From industry, we have Merck and Huntsman and Talga. And it's a holistic project where at the heart of it, we are building a 1,000-ton capacity plant to manufacture styrene. And around the side of it, we're looking at the ecosystem to create the new supply chains. So my role we're in the process of changing coordination officially because Circa's leading this project. So coordination is about the smooth running, some of the admin side of it connected to funding, etc. The project from the BBIJU is 11.6 million euros. And then on top of that, it's about maximizing and optimizing the opportunity, because here we are with 11 amazing organizations. And then on top of that, a whole further ecosystem of government, local government, national, European levels, industry, supply chains that are all there about making this ecosystem a reality.
Great. I mean, it's really interesting, and I've come across that project and lots of the Horizon projects. There's some amazing stuff out there, and we're in conversations with lots of those people that are managing those projects, so we can also help their visibility and their connectivity through our digital platforms and our in-person events as well. So there's
Brilliant.
I think the opportunities out there, because without getting into lots of stuff now, but there's a lot of great stuff going out there that I actually think can be amplified much wider through sort of media and connectors, which is what we are in essence. So it'll be great to sort of take that up with you off of screen.
I look forward to it.
Great.
I do indeed.
Okay, so listen, before we end this episode, I would just like to invite any collaborative bio pioneers to feel free to contact me at paul@biomarketinsights.com, and let's explore what we can do together. There's loads of great stuff that we can collaborate on. So Dr. Sarah, that pretty much wraps up our conversation today. On behalf of myself and my viewers around the world, I'd just like to thank you for your time, your insights, and wish yourself and everyone at Circa Group all the very best for the future, and I hope to see you soon.
Thank you, Paul. It's been an absolute pleasure, and please look forward to talking anytime.
Yeah, that's absolutely wonderful. Thanks very much. See you soon.
Bye.
Bye-bye.